Hi everyone, let's talk about the point line distance formula on the Cartesian plane. Let's say we have a line and that its equation is ax plus by plus c equals to 0, and we're gonna assume that a squared plus b squared is not 0, which means not both of a and b are 0. And this is a fair assumption because otherwise we don't actually get a line. And suppose that we have a point P, which is x naught, y naught. And we want to find the distance between this line L and this point P. And by distance we mean the perpendicular distance from P to L. So it is this distance that we want to find. Now I'm going to tell you the formula from the beginning. It's the absolute value of ax naught plus by naught plus c divided by the square root of a squared plus b squared. And we're going to try to derive this formula based off of knowing it already. So we're going to derive it completely logically, but we're going to gain some inspiration from the formula itself. So there are a couple of edge cases. The first edge case is a equals to 0 and b is not 0. In this case, the line is horizontal. And the second case is where a is not 0 but b is equal to 0. In this case, the line is vertical. I'm going to leave these two edge cases to you because it's easy to verify that this formula works in those cases, and that allows us to assume that a is not 0 and b is not 0. So that's going to be a convenient fact for us. It's going to allow us to talk about slopes very easily. So what we want is, let's go back up to the diagram. P is x naught, y naught, and this point here we're going to call it x1, y1. And what we want is the distance between these two. So what we're seeking is, by the distance formula, x naught minus x1 squared plus y naught minus y1 squared, and the square root of the whole thing. So that's what we're going to be aiming for, and that's what we'll find in the end. Now, before we begin, I just want to mention a sort of lemma that's going to be useful to us. We know that the slope of the line, if you put it in slope-intercept form, you'll find that it's equal to negative a over b. So that means the slope of the perpendicular segment is the opposite reciprocal of that, which is b over a, and that's also equal to y naught minus y1 over x naught minus x1. And we can write that in a different form, which is a y naught minus y1 minus b x naught minus x1 equals to 0. And we're sort of looking ahead a bit, but we're going to be squaring this so that we get a square y naught minus y1 square plus b square x naught minus x1 squared is equal to 2ab y naught minus y1 x naught minus x1. So this formula here is going to come in handy to us in just a minute. So let's take a look at the formula that we want, which is over here. This formula has the numerator ax naught plus by naught plus c in an absolute value. So let's square the numerator and let's work with that. We get that the square of ax naught plus y naught plus c is equal to, we're going to replace c with a x1 plus b y1, since x1 y1 lies on the line, so we get a x naught plus b y naught minus a x1 minus b y1, and then we square it, and that's equal to a x naught minus x1 plus b y naught minus y1 squared. Now we're going to square it, so we get a square x naught minus x1 squared plus b square y naught minus y1 squared plus 2ab x naught minus x1 y naught minus y1. And now our formula up here, this one, is going to come in handy. We're going to use the substitution for the final expression that we have here. So what we get is that a square x naught minus x1 squared plus b square y naught minus y1 squared plus a square y1 minus y naught minus y1 squared plus b square x naught minus x1 squared. And now we can factor it, so we get a square plus b square times x naught minus x1 squared plus y naught minus y1 squared. And now we're just going to do some isolation. So we know this is the left side and this is the right side. So we just isolate the distance formula expression, and what we get is that the distance between P and L is equal to x naught minus x1 squared plus y naught minus y1 squared square root, and that is equal to ax naught plus by naught plus c absolute value divided by the square root of a square plus b square, as we expected it to be. So the distance between P and L is what we wanted it to be. Thank you for watching, and I'll see you next time.